Hello. Today we're going to talk about the projectile trajectory and what kind of mathematical formula. Okay. All right. So we know when we're a projectile, it's on a level ground, it looks like that. So we are asking the question, what kind of shape is this, right? The shape of the trajectory, right? For a projectile, right? So projectile goes out, right? Here's a V0 and with the angle, right? All right, so let's look at the mathematics. So we have, let's see. So we call this one X, and we're gonna call this one Y, right? So at some point, let's say this point there, right? And you arrive at some kind of X, right? So you have an X there, and then you arrive at some kind of Y, right? So that's your origin right there. This is your origin. Okay. And then so your Y is like right there. Okay. So we know the equation of X is equal to Vx0 times T, right? So we took the amount of time that we took to get here is T. And then Y is equal to Vy0T. And then let's just say, you know, we say the G is this way here, right? So we can say 1/2 a GT squares, right? So those are from the kinematic equation, right? So this is from kinematic equation, kinematics equation, right? You have this too, okay? So let's see what does, let's see, you want to look at the Y versus X, right? So when you say the shape, you're asking the question Y as a function of X. How does it look, right? So that's the question. Mathematical formula for the trajectory, right? For the trajectory. So you have Y and you have X. So Y as a function of X, right? All right, so let's see. So Y, so from equation 1, equation 2. So for equation 1, we have T is equal to X divided by Vx0, right? So we're going to get rid of T, right? So our objective, we're trying to eliminate T. So we can get to phi as a function of X, right? All right, so let's put that in. So let's substitute 3 into 2, okay? So then you have Y is equal to Vy0, and then X, and then divide by Vx0, okay? And plus 1/2 G, and then T, right? So that's X right there, right? X, Vx0, and then square, okay? So keep in mind, I'm going to change in color here so you can see a little better, right? So keep in mind, you know, so V0 is given. So V0 is given. So that means the Vx0 and also theta is given, right? So both of these are given. So Vx0 and Vy0 are known, right? All right. So these are known. So we're going to call that A. And then this are known right there. See that? G is 10. And that's known right there, right? It's a square there, okay? We're going to call that one B there, right? So this is Vx0 squared, right? So now with that, we're going to write Y is equal to AX plus BX squared, okay? So that is your formula you're looking for. And that is from math, right? This is a parabola. That's a parabola equation, Y. So Y as a function of X, it's equal to AX plus bx squared. Okay, so when you plot them, it should look like a parabola, right? So that indeed is a parabola. Right? That's a parabola. So parabola in Chinese called 抛物线, right? 抛物线. So it's a little bit of language here. 抛物线. All right, so the next subject we're going to talk about is also in this trajectory and the range that we talked about yesterday. All right, so I'm going to continue the lecture. I'm going to talk about, I'm going to say the C beyond the equation, C beyond the range, right? Range formula that we derived before, right? So the range is equal to, let's say, is V0 squared and then sine 2 theta 0 divided by G. Okay, let me double check. All right, V0 squared sine 2 theta 0 divided by G, right? All right, so what are we saying is that we have, well, we always have x's first, x and y, okay? And then you have the parabola, right? Okay, and then you have this initial velocity that's given. So, you know, just say that, oh, I know the initial velocity, that's V0. And this is my initial angle at when it's first going up, right? The velocity with respect to x, the angle is theta 0. Okay, so now we're going to look at this equation and we're going to say, well, V0 is given, okay? So it's basically a constant now. So say that's equal to 10 meters per second, right? And G is known, so G is 10, right? Okay, so now we can just kind of look at this and say, well, that's just a number. So that number there is just equal to 10, right? Right. So you know that's a constant right there. And theta 0 is also given, but it has a range, okay? So this one is fixed, but this one says, I'm going to say, let's just don't say this is given. Let's just say theta 0 can vary, right? From 0 to 90 degrees, okay? So if you can shoot it this way, that would be 0, right? If you can shoot it this way, you know, then that would be 90 degrees, okay? So this case would be 90 degrees, this case would be 0 degree, right? So that would be 0 degree, and that would be 90 degrees, okay? So now we're looking at this equation, we ask yourself a question and say, for what angle that I have, would I maximize, right? So I'm trying to maximize, right? So if you're a football player, you're a quarterback, right? So if you're a quarterback, 四分卫, right? Quarterback. And you want to throw a ball, right? So what angle should I throw? Then I want to get the largest distance, right? The range. So I want to maximize this, and then I want to change. I want to vary the theta 0. So that's the objective. I'm changing the theta 0, and I want to make this R as big as possible. And look at this. This is constant, right? But theta 0 can change, right? So then I know this is R times a constant times sine, right? And then, you know, 2 theta 0. So how do I make this the biggest when I change from 0 to 90 degrees? Well, obviously, mathematically tell us that if this one, you know, the largest you can get is 1, right? For sine function. So then you set this equal to 1, then you realize it that it has to be sine 90 degrees. So then that tells us that theta 0 has got to be 45 degrees. Okay, so that's our objective of the day. When you see beyond the range formula, you see that it gives us a hint that if your V0 is fixed, okay, it's given, and G is fixed, and there's no air drag, right? No drag. Then theta 0 can vary, and you're on a level ground, okay? And then the other assumption is you're on a level ground, okay? Level ground. Then when theta 0 is 45 degrees, it will give you the largest, right, it will give you the maximum R that you're looking for. Okay, and that's what the quarterback should throw at, is at 45 degree. Okay, in general, if those conditions are true. All right, that's all we have for today. Okay, see you next time. Yeah, hopefully you appreciate the formula that we go through, and it can relate to real life.